I've got a fun show and tell video for you today. I'm going to demonstrate how we can take data from this NIR device, which we've looked at many times before, and deploy it on a device like this, a small credit card sized computer called a Raspberry Pi. I then want to integrate hardware that looks like this, where we have two LEDs that'll be the output of our model. Welcome back to the channel. My name is Chris and I'm a PhD measurement scientist with expertise in deploying measurement science in the real world. So thinking about how do we take these measurements outside the lab and into the spaces where we want to collect them or where the samples are located. And so in today's video, I'm going to demonstrate how I can build a model based off of currency using NIR data on my Mac computer, the primary computer I use, and then deploy that model on a small credit card sized computer called a Raspberry Pi. And so we're going to take that pickled model, put it on this breadboard, and then we're going to use the output of that model to illuminate a green light if we have authentic money, or a red light if this is not a US dollar. Let me show you how we can do that. To begin, I'm going to read in data from my NIR on a lot of different currencies, but I'm going to build a one-class support vector machine model on just the US dollars. And the point of this model is to predict whether we have US dollars or some anomalous novel material that will be a currency from elsewhere in the world. As you can see here, I'm dropping a column called measurement description, and I'm going to set my training data, my NIR data, based on where Y equals USD. And so this will allow me to filter down to just the classes I want as part of my one class model. And then I'm going to Z-scale the data and then prepare a support vector machine using an RBF kernel and my gamma set to auto, as well as a new of 0.001. Next, I'm going to predict on my full data set and see how the model performed. As we can see here, I have an accuracy of 0.94 and an F1 score of 0.89 and 0.96. I'm going to visualize this highly dimensional data using a 2D principal component analysis. On this figure below, we are seeing a PCA projection of the support vector classifier output. So where I have my green points, these are where the model is predicting the NIR samples, the USD. And where I have my red samples, this is where the model has predicted not USD. These are the outlier samples. And I have a few cases where I have some misclassifications. The next step I'm illustrating is pickling the model or saving the model with all of its coefficients. To do that, I'm going to use this with open syntax, save the model as svm_model.pickle, and I'm going to dump my support vector classifier model. If I were to read this data back in, I would just use the with open, call this model, and then pickle.loadf to bring the model back in, and then I can predict those results using the model we just built before. However, now I want to switch over to the Raspberry Pi to demonstrate how we can use this model in a completely different context. Now we are looking at the Raspberry Pi screen. I'm actually remoting in from my laptop to the Raspberry Pi Connect, and we're now looking at this computer shown on my secondary screen. And what we need to do next is connect the breadboard to those GPIO pins at the top. To do that, I will take this connector here and attach this below. To put this together in this manner here. So we have this breadboard connected to this computer. If you want videos on how I actually wire this up, I will produce those. And then I'll also show some B-roll where I'm connecting this circuit, but it's a pretty simple circuit with two resistors, two LEDs, and some wires to connect it. In order to load the output, I've already sent the pickled model to this computer. I'm going to go to my folder, my NIRS.py, and then run my NIR LED. Here's the model that I'm going to read in. I'm going to run that in the Thonny Python environment. And I should state that this is the data I'm going to be using for this demonstration. This is the Python code I have. So you see I have pandas, time, OS, and pickle in order to read in my pickled method. But I also have this GPIO0 import LED module there. And this is how I'm going to assign the location of my LED lights. Of course, this assumes I have all the proper wiring. Next, I'm going to use the same with open statement I just demonstrated to load my pickled model right into this environment. And then I'm going to create a list of files where I'm going to scan my currency folder where I've already brought over some of my representative files from both NIR materials and potentially anomalous materials or those currencies from around the world. Next, in this for loop here, I'm going to loop through my file list. I'm going to save that as sample, and then I'm going to run that sample through my model, where if this model output is 1 or inlier, it's going to light up green, wait 2 seconds, and then turn the green light off. Otherwise, it's going to light up red, wait 2 seconds, and then turn the red light off. To run this model, I simply just select run script. It'll run through the files, and you will also see what the LEDs would do in real time. And just like that, we ran through all the files with the outputs that we wanted. We have our green lights for the samples that are inliers and the red light for samples that are outliers. Now, of course, we can extend the utility of this computer, this Raspberry Pi, for many other use cases. Here is just a simple demonstration. Ultimately, I like to connect the data directly. So use an API that will go right from the cloud where this source data is stored, download it into my Python environment, and then process through a model. But this is a great way to simulate the flow of data from the raw sample, signal transduction through our device, data processed in Python, models built, and then deployed on a Raspberry Pi for real-world context. So now you can begin to see how we're building out an entire ecosystem where we can build, deploy, and test these real-life models. If you want to see me apply this to other things where maybe the output is text from plastic prediction, let me know in the comments below. If you want me to demonstrate wiring this up and maybe building even more sophisticated circuits, let me know as well. In the case, I'll see you in the next video. Peace.